Hello, am I audible? Okay. Yeah. Sorry guys, I do not have the access to our one notebook today because I am not using my device. So we have to start. We have to write the writing on the whiteboard. My network speed is all right, so I don't know why is it happening, but I don't think it will sustain. Faisal, is it okay? Am I audible to everyone?
Yes, sir.
Uh, I think my network speed is okay, so I should be audible to everyone. I don't know whether, I mean, can someone reply me if I'm audible or not?
Okay, am I audible now? Okay, cool. Everybody has to write because I will not be using one notebook today. So you'll have to start fresh. Yeah, so I think we were on chain rule differentiation. So I have given you one exercise in homework and two questions which were written on the board that day. So can someone remind me what were the questions? Any one of you can please speak up and tell me the questions because we are going to solve them first today. And after that, we will be starting our proper differentiation. So this is where the basics of differentiation. If we are good with it, then we will be comfortable in most of the chapter. But before that, can someone remind me the questions which I have written in the last class? Okay. So one question was to find out the differentiation of fx was given whole root of sine cube x, right, into cos of 2x. And another question was, okay, so we'll be reaching, I mean, we'll be solving that question also, but first let's start with this. So has anybody solved it? Okay, thank you, Faisal. Second question was this. That we had root over sine log x square. Yeah, so let's first start with root over sine cube x into cos 2x, and then we will reach to sine of root over sine of log x square. Yeah, has anybody solved it? Okay, I'll give you 1 minute. Please solve it if you can. Root over sine cube x into cos 2x. We know the rules. If there is a power on the whole expression, then we deal the power first. We know how to deal the power. Then, and it's root. So we already know the shortcut for root, right? 1 by 2 root inside same quantity. So first we deal with power, then we deal with the inner function. Inner function is a multiplication of two functions, sine cube x and cos 2x. Sine cube x will also need chain rule and cos 2x will also need chain rule. But when they are both multiplied, so we will also be applying product rule, right? If anyone is done, please let me know. No, it's not the power, Shahid, this time. It's the input. 2x is the input inside cos. If you want, then I can also give you power. Let's take power 4 in this case, if you want it. But I don't think in the original question we had power. But if you want, so we can change it to cos to the power 4 2x. Yeah, so let's start with first dealing the power. So it should be f dash x is equals to its root. So it should be 1 by 2 root, and inside will be the same quantity as it was given. Right. Then in multiplication. So first we have dealt with the power, constant power. Now we will reach to the function. The function is sine cube x into cos to the power 4 2x. So it needs, to differentiate the whole function, we need to apply the product rule. Product rule says differentiate first, keep second as it is, then keep first as it is, differentiate second, right? So differentiating the first function, it is sine cube x, right? Is sine cube x. So sine cube x, money first is power, right? So we'll be dealing with the power first. It should be 3 sine square x. Right? Now after power, we got sine x. Right? Sin x is cos x. So this will be the differentiation of first function into cos to the power 4 2x is as it is, plus now first function will be as it is and differentiation of second. Now differentiation of second means cos to the power 4 2x. So first we will differentiate power 4. So power 4 will be 4 cos cube 2x. Right? This is power. Then we'll reach to cos 2x. Now it is not cos x, right? It is cos 2x. So when we encounter cos 2x, so we'll only focus on cos first. Cos is sine, or rather minus sine. And inside it will remain 2x. Now I will reach to 2x. The differentiation of 2x is 2. So that will be your complete answer of f dash x. We can further obviously simplify this. So f dash x will be 1 by 2 root over c. This value, what is the value of fx? Fx is root over sine cube x into cos to the power 4 2x. So this is basically nothing but fx. The quantity with the root is whole fx. So I can write it 1 upon 2 fx, right? Just for the simplicity. I don't want to write the whole expression again and again. So for the simplicity, I'm writing 1 upon 2 fx because the fx value of fx is already given. And this is basically the value of fx only. And this becomes 3 sine square x cos x cos to the power 4 2x. And this becomes minus, because a minus is inside minus sine 2x, minus 4 into 2 is 8. This is sine cube x, then sine 2x, then cos to the power 3 2x. This is your complete answer. I mean, we can further simplify it by taking some things from, but yeah. Did someone got it correct? Raise your hand if whatever you solved is correct. Okay. Let's start with the second one. सबसे पहले पावर, उसके बाद लेफ्ट हैंड साइड से स्टार्ट करेंगे, राइट हैंड साइड तक जाएंगे, पावर्स का ध्यान रखते हुए। जहां भी पावर आएगी पहले पावर को ट्रीट करना है, तब अंदर जाके फंक्शन को ट्रीट करना है। करेक्ट है शायद। So first should be we treating this power root. So this should be 1 by 2 root. Inside root will be same quantity, which is basically gx. I mean 1 upon 2 root sine log x square, right? And that is what? Gx. You can also notice the pattern. Whenever this root is involved, the function's differential is always like this, 1 upon 2, the same function. Now I will reach to sine of log x square. Sine of log x square में सबसे पहले साइन को करूंगा, है ना? साइन का होता है cos. अब क्योंकि अंदर x के अलावा कुछ और है, तो मैं उसको as it is लिख दूंगा. Now I will reach to what? Log. Log of x square should be, no, this is not log x. This is log of x square. Log of x square what? Log of x square should be 1 upon x square, 1 upon input. Now I will reach to x square. X square is what? 2x. So I can further simplify this expression as 1x will be cancelled out, 2 will be cancelled out. So it will only become cos of log x square divided by x gx. So the final answer is this one. Means it is not necessary to write the answer in the form of gx or the function itself, but if you're writing it, so definitely you're saving your time. One thing is true. Okay, so can we move ahead? If anybody hasn't written, just he or she can raise the hand. Okay, cool. Okay, you can also ask me any doubt if you faced in the NCERT exercise. Okay, in that case, we can proceed further. Now, we know about the basic differentiation part. We know what are the rules of differentiation, and we also know the basic formula of the differentiation, right? So after this point, we need to understand what kind of different functions or what kind of different conditions, situations can be created while you differentiate an expression, right? So these expressions can be changed. We will apply chain rule in different ways. I mean, on different functions. But the basic rules and the basic formula will be same. Okay. So the first topic we are going to start will be differentiation of or derivative of implicit function. Now you need to understand in each part, there will be a special type of function or there will be a special kind of expression. You need to understand that expression first. Derivative part, you have already gone through the derivative part, so you can easily understand how we are going to differentiate that expression. But before that, you need to understand what kind of expression we are talking about. Right? So in this, the important character is implicit functions. What are implicit functions? So functions can be categorized. Every expression of function can be categorized in two parts. One is explicit function and another is implicit function. So first, let me discuss what are. Oh, sorry. So the first part is explicit functions. Now, till the time, till now, we have mostly used explicit functions. Now, what are explicit functions? We have mostly seen all the explicit functions only. So explicit functions are those functions in which you can actually define y in terms of x. For example, so the definition says the functions or the expressions in which y can be explicitly defined or clearly defined in terms of x. For example, y is equals to sin x. This is a trigonometric function. One side is y, all the y is on one side and all the x is on one side. Yeah, for example, y is equals to e to the power x. This is an exponential function. One side is y, one side is x, right? So your y can be easily defined in terms of x square plus x, right? So all such functions in which y can be defined in terms of x are known as explicit functions. But on the other hand, we also have these second kind of functions which are known as implicit function. Now, first of all, what functions are implicit functions? All the functions or all the expressions in which you cannot divide y and x separately. You cannot separate y and x. Right? Now I'll show you some example. So you can write in which y and x cannot be separated. For example, let's see this function. This is x.
Sir,
Yes.
explicitly defined means clearly defined.
Yes. Explicitly meaning clearly,
Yes.
transparently. And in the case of implicit functions, you'll see that y and x cannot be separated. And you cannot define y in terms of x completely or x in terms of y. You will not be able to do one thing. Both the things. Neither you will be able to define y in terms of x or nor x in terms of y. So this will be something like that. For example, if I take this, it is sin x y is equals to 0. In this function, you will not be able to separate out x and y. If you take x common, then x is also inside sine. So if you take all the x to one side, y will also go to that side. So you can't separate x and y. You can try this. In fact, we have easy examples also. Easier than this. In fact, we can only write it in two terms. So let's try to separate this. Tan of x upon y is equals to e to the power xy. Will not be able to separate x and y here. If you take tan to the right hand side, it becomes tan inverse, but still x and y both are in second term. And if you take e to the left hand side, then it becomes log. I'm telling you the transformation. If you take e to the left hand side, it becomes log. So you can write it like this: log of tan x upon y base e is equals to xy. If you take y, then also x and y are both sides. I mean, you are not able to define x in terms of y because there is a x inside tan. And if you take x to the left hand side, then the expression becomes y is equals to 1 upon x log of tan x upon y. You can clearly see that y is on both sides. So you will not be able to differentiate or separate x and y in this case. Now, how to differentiate these functions? So this will be our topic. And before we actually go to the topic, so everybody understood, right? What is explicit function and what are implicit functions? If I'm not, if you want to ask anything, please feel free. Okay. So some of the functions, now what do we know about implicit functions? Like what are the things that we want to know? Implicit functions are generally complex, okay? Because x and y will be included on both sides, right? You will not be able to separate out x and y. So implicit functions generally will look complex to eyes, right? And what do we need to do? We don't need to do anything fancy here. I mean, there is no formula. There is no. They will give you formula in NCERT and books, but there is no formula actually. So and there is no formula. Money. You don't have any new added formula for this implicit functions. You just have to carry out your steps or rules which you have learned during chain rule and product rule and all these rules and all the formulae. You just need to remember them, right? And you need to understand one or two things which are which are basic things which which we couldn't talk about in the earlier classes because I wanted you to understand how the differentiation process is going. Now, after this, we will understand what are some other things that we should know about differentiation. And also, we have talked about the meaning of dy by dx, right? I will also talk about that a bit so that you can understand how the differentiation of implicit functions is going on. So, okay. So these kind of functions are implicit functions. Now, while differentiating them, before differentiating them, we need to understand certain things. The things are these. Let's say we are differentiating we have written this expression dy by dx. So what does this mean? This means that we are differentiating y with respect to x, right? Basically, there are two variables, y and x, and y is dependent on x by some rule. Rule can be anything. Rule is basically what? The expression. The expression is basically your rule. That is how x and y are connected through that expression. That expression can take either explicit shape or implicit shape. I mean, that expression can be anything, either from the first examples that we have taken, y is equals to sine x, y is equals to e to the power x, or that rule can be like tan x upon y is equals to e to the power x. Right? Here, we are basically differentiating y with respect to x. That is why I have written dy by dx. Now, let's say an expression is like this. Z is equals to x plus x square. Now I have two other variables, which are what? X and z. So I can basically find out differentiation of z with respect to x or differentiation of x with respect to z, whatever I want. If I want to differentiate the whole expression with respect to x, I can do that. If I want to differentiate the whole expression with respect to z, I can do that. But if I want to differentiate the whole expression with respect to y, right? So the first question that I should ask is y also a variable in this? Is y also associated to x or z in some way? And if the answer is yes, then what is that rule? So basically, what is that equation? Right? So if an equation is not given, then I will assume that y is not associated to z and x in any way. Right? But I can definitely differentiate a variable with respect to another variable if both the variables are known to me. And known to me, there should be an equation in which they are used. इट इज नॉट नेसेसरी कि z x y तीनों एक ही इक्वेशन में हो, दो इक्वेशन भी बना सकते हैं अलग अलग, but I can differentiate a variable with respect to another variable at any point of time if I know both of them, right? Because that only makes sense. If I don't know a variable, what is the point of differentiating with respect to it, right? So this was first thing. Now let's say, let's start with a very basic example. Okay, first, so let's say I have this expression y is equals to x square plus y, or sorry, minus y, or let's take minus y square. Okay, y is equals to x square minus y square, or rather, before this, let's take first y is equals to x square minus x. Now I am taking y is equals to x square minus x. Now, if I say, you understand the meaning of things. If I say differentiating the whole expression or differentiate the expression with respect to x, what does that mean? It means that I will differentiate the whole expression with respect to x, that is left hand side as well as right hand side, and it does not change the meaning of the expression. I can definitely differentiate the whole expression, right? So the expression becomes, if I differentiate the left hand side is y, I am going to differentiate this with x, with, so this will be dy by dx. If I go to right hand side, the first term is x square. I know the differentiation of x square with respect to x only, so it should be 2x, right? Minus, then the differentiation of x with respect to x will be 1. If I want to write the intermediate steps as well, this should be something like this: differentiation of x square with respect to x minus differentiation of x with respect to x, right? Which will turn out to dy by dx is equals to, this will become 2x minus this will become 1. So the answer, or if I have been asked to find out the dy by dx in this case, that should be 2x minus 1, right? Okay, we'll go through 1, 2, 3, 4. I mean, we will go through 2 more examples before going to the derivative of implicit functions. But during the process, you will be understanding the derivative of implicit functions only. Then we can start directly the questions. After these 2 questions, you can start the questions. You need to understand these examples first. Is it done, everyone? If you are writing, then you can just raise your hand. I'll get to know whether you are writing or not. If not, it's okay. Cool. Now let's take second example in which I'm defining y like this. Y is equals to,
Can you just scroll up?
wow, we can't scroll up here. We need to do undo many times. So Shavis, you have to be attentive in the class. Just tell me whenever I'll ask you. You can raise the hand, I'll stop. I'll wait जब तक भी तेरा hand raise होकर रखेगा.
Well, sir.
Okay, so let's define our y as y is equals to sine of x square, right? So if I want to differentiate, or if I want to differentiate the whole expression with respect to x, or I can say if I want to find out dy by dx, what I will do, I will differentiate the whole expression with respect to x. So this will look something like, just a minute. So this will look something like differentiate both sides with respect to x. So it becomes dy by dx, right? Dy by dx is equals to, first I'll differentiate sign. So it becomes cos of, okay, I'm going to write all the steps. I'll not write directly this time. That is the whole purpose of this actually. So I'll not be writing directly. Rather, I'll be writing the all the steps and then we will be writing the answer. Yeah. So this should be dy by dx of, सबसे पहले हम करेंगे साइन का, तो मैं इसको ऐसे लिख दूंगा और उसके बाद मैं करूंगा एक्स स्क्वायर का, राइट? दिस इज हाउ वी विल बी प्रोसीडिंग. So what I'll do is I'll write cos of x square here, and then I'll be writing 2x here. Right? This should be the answer. Now let's change the example a bit more and let's write it as y is equals to sin y, or rather y is equals to x into sin y. Y is equals to x into sin y. Now if I differentiate both sides with respect to x, what happens is the left hand side becomes dy by dx, right? Dy by dx. The right hand side is a product of two things, x and sin y, right? Now remember, this is also not sin x. Sin x का differentiation x के respect में कर रहे हैं, चलेगा. Sin y का differentiation x के respect में कर रहे हैं, that is a different thing. Sin x, the differentiation of sin x with respect to x is what? Cos x, right? But the differentiation of sin y with respect to x is chain rule. We directly go to chain rule, okay? Why? Because we don't know what is the differentiation of sin y with respect to x. We know the differentiation of sin x with respect to x, right? Okay, so now we have two things here, x and sin y, both are in product. So we will be applying product rule. Product rule says differentiation of first, differentiation of x. So d by dx of x into sin y as it is plus x as it is, d by dx of, that is differentiation with respect to x of sin y, right? Now the differentiation of x with respect to x is 1 into sin y plus x as it is. Now the differentiation of sin y with respect to x, okay. So we go to sin first. The differentiation of sin is cos y. Y will be as it is. Then we go to y. The differentiation of y with respect to x is dy by dx. The differentiation of y with respect to x is what? Dy by dx. And there was a dy by dx in this side also. Now the answer of dy by dx actually includes two terms. So we will be combining them. Just a minute. Yeah. So dy by dx is equals to sin y plus x cos y dy by dx. We can also replace dy by dx with y1 as we want, because y1 is also a very common abbreviation used for first differentiation or dy by dx, or we can also let it be as it is. So dy by dx, and I'm also combining this term, taking this term to the left hand side, right? So this becomes minus. If I take dy by dx common, this is 1 minus x cos y is equals to sin y. Hence, your dy by dx becomes sin y divided by 1 minus x cos y. dy by dx is equals to sine y divided by 1 minus x cos y. This is your final answer for this question, and this was an implicit function only. So all the implicit functions can be covered using the same rules which we have learned. Nothing fancy. We don't need to learn a new rule for this, because there is actually no new rule. Please feel free to ask your doubts, क्योंकि अभी हम फिर सॉल्व करना भी स्टार्ट करते हैं क्वेश्चंस. बट प्लीज फील फ्री, जब भी कहीं पे डाउट हो तो एकदम पूछ लो. ओके, कैन वी प्रोसीड? अगर किसी ने नहीं लिखा है तो जस्ट रेज योर हैंड. कूल. Now using the same, we can also find out the differentiation of inverse trigonometric functions. So let's understand with two of the examples. We will be having 4 new formulae here. The differentiation of sine inverse x, cos inverse x, tan inverse x, and cot inverse x. Although we will be needing sec inverse, we will not be needing sec inverse x and cosec inverse x. Most of the times it will only be sine inverse, cos inverse, and tan inverse. You will not even be needing cot inverse, but still we will be writing down all the 6 formulae. But first, let me prove any 2-3 of them. फटाफट से we'll prove. मतलब prove क्या, बस just understand the process how we are actually finding out the differentiation of inverse trigonometric functions. देख लो, अभी तक हमने inverse trigonometric function का कोई फॉर्मूला भी नहीं लिखा, क्योंकि अभी वो नहीं आता हमें करना. We know how to differentiate exponential function, algebraic function, right? Constants, trigonometric functions, logarithmic functions, ये सब हमें आता है. Okay, we can proceed, right? Good. Just चलो मैं तुम्हें दो, I'll take cos inverse x and cot inverse x, because sin inverse x and tan inverse x is already given in the book. So I will take cos inverse x, how we are finding out the differentiation of cos inverse x, right? And cot inverse x. तो हम dy by dx find out करना चाहते हैं. We want to find out dy by dx in both the cases, right? dy by dx माने क्या? Differentiation of cos inverse x पहले केस में. भाई dy by dx माने you're basically differentiating y with respect to x, and what is y? Y is cos inverse x. So you basically want to know this thing. Basically want to know this thing. D of cos inverse x with respect to x. There is a formula for this, right? There's a formula for this, and the formula is this. But we will reach to this formula. हम ये जानना चाहते हैं, इसी को dy by dx भी बोल सकते हैं, because you can replace cos inverse x with y. So this is basically dy by dx only. We want to find out this. We will be writing down all the 6 formulae later on, but first we want to find out these 2 things. Now the process is, we don't know yet how to differentiate an inverse trigonometric function, right? But we do know the differentiation of trigonometric functions. So what we do is we just go through the process, what we know, and can we modify the given expression in terms of what we know, right? And then differentiate the function. So in this case, y is equals to cos inverse x. We don't know the differentiation of inverse trigonometric function. So what we do is we first change it. to a trigonometric function. How can we do that? We can take cos inverse to the left hand side. So if we take cos inverse to the left hand side, it becomes cos. So it is cos y is equals to x. Cos y is equals to x. Now differentiating both sides with respect to x. Why? Because I want to find out dy by dx, right? So that is why I am differentiating both sides with respect to x. Now the left hand side is cos y. I don't know the differentiation of cos y with respect to x. So I apply chain rule. So first I'll go to cos. Cos is minus sine inside same thing, whatever is written. So minus sine y. Then I go to y. Y with respect to x is dy by dx, the thing I want, is equals to differentiation of x with respect to x is 1. Right? So this dy by dx actually becomes what? This is 1 and this is minus sine y. I take minus sine y, which is in multiplication with dy by dx to the right hand side. So this becomes minus of sine y. Dy by dx is equals to minus 1 upon sine y. Now see, the original function was y in terms of x. Right now, I don't have the final answer in terms of x. I know, the final answer right now is in terms of y only, minus 1 upon sine y. But I can definitely change it in the form of x. How? Using this expression. I know the value of cos y is x square. Cos y is x. I can find out the value of sine y in terms of x from here. How? I know that sine y, or rather just write it like this, sine square y is equals to 1 minus cos square y. Correct me if I'm wrong anywhere. You can write sine square y plus cos square y is equals to 1, right? So sine square y can be written as 1 minus cos square y. So sine square y will be 1 minus x square, because cos y is equals to x. From here, you can find out that sine y is equals to plus minus root over 1 minus x square, right? And basically the value of sine y will be taken positive here. The positive one will be taken in this case. So this will be, in all the cases, the positive one will be taken. Even we can actually, this condition does not hold in this case due to the values of inverse function of trigonometry. But we can write sine y is equals to root over 1 minus x square. So dy by dx is equal to minus 1 upon root over 1 minus x square. But we can easily find out the differentiation of anything, any ITF using the same expression. Interpret it like this: y is equals to cos inverse x, है ना? So dy by dx हुआ minus 1 upon root over 1 minus x square. Now, for example, cos inverse x ना होता. Let's say this is not cos inverse x. This is cos inverse of x square. या cos inverse of log x. In that case, the function would have been composition of function, right? तो मेरे को cos inverse x का पता है, मेरे को cos inverse log x का नहीं पता है. तो cos इनवर्स log x का नहीं पता अगर मुझे ये दे दिया जाता है। तो how would I have done this? I would have done dy by dx is equals to minus 1 upon root over 1 minus, सबसे पहले मैं cos इनवर्स पे जाऊंगा। cos इनवर्स का होता है minus 1 upon root over 1 minus input square. This x was input, right? In this case, the input is log x. So this should be log x whole square. This will be the differentiation of cos inverse. Okay. And then I'll go to log x. Log x is 1 upon x. So interpret the ITF like this. Minus 1 upon root over 1 minus x square. मतलब आपको सीधा सीधा फॉर्मूले से याद रखना है, बट x की जगह अगर कुछ और आता है तो you will do that here also and apply the chain rule. Right? Okay, can I remove this? Okay, so we can definitely write cot y is equals to x. Right? Cot y is equals to x. And you know there is a formula cos x square x minus, or sorry, cos x square y minus cot square y is equals to 1. You can write like that. So cot square y or cos x square y, no, cot square y, cos x square y is equals to 1 plus cot square y, which would be 1 plus x square. Right? Okay. So remember this in the mind. Also, you can say that cosec y is equals to root over 1 plus x square, but we don't need that. But we can definitely use the same thing which we have done because we will be needing this. Okay. Okay, so let's start with this one. Differentiate with respect to x on both sides. If I differentiate both sides with respect to x, the first thing here is cot y. Cot y is again chain rule because this is not cot x, this is cot y. Right? So cot y is minus cos x square y minus cos x square y into dy by dx, the differentiation of y, is equals to x is differentiation of x with respect to x is y. Hence, we can write dy by dx as minus 1 upon cos x square y. Let's call this equation as 2. Let's call this equation as 1. Hence, we can write from second equation using 2. So this will be changed to minus 1 upon 1 plus x square. I mean, implicit derivative of implicit functions is easy if you are good with your chain rule. Just have to apply the chain rule multiple times. There will be an expression on left hand side as well as right hand side. Simple expression नहीं होंगे, थोड़े tough होंगे. These are simple because we were only doing inverse trigonometric functions. That is why these were simple. Anji, can we proceed? Can I write all the formulae of inverse trigonometric functions now? If you are done with this. Cool. Chavez, you're done, right? Okay. So first of all, let's write derivatives of inverse trigonometric functions. Derivative of inverse trigonometric function. So the first one is differentiation of sine inverse x. The differentiation of sine inverse x is 1 over root 1 minus x square. And the differentiation of cos inverse x is nothing but this with a negative sign. तो बेसिकली तुम्हें दो के लिए एक ही फॉर्मूला याद करना है. First, second will be same. Similarly, third, fourth will be same. Only the difference of a negative sign. So tan inverse x is 1 upon 1 plus x square. And then cot inverse x is minus 1 upon 1 plus x square. And but always remember that what's the domain of x. So the domain of x is different in all the cases. I mean, in this case, x can only take any value between minus 1 to 1. So both of them, x belongs to minus 1 to 1. Then for both of them, x belongs to all real numbers. And for both of them, x belongs to either minus infinity to minus 1 or union 1 to infinity. Now, these were basic things. The good questions from this exercise will be based on when you differentiate a trigonometric functions, when you when you try to differentiate an inverse trigonometric function, but the inverse trigonometric function is not that easy. So you will have to basically apply some reduction technique, which you have learned in ITF, and then you will be doing. तो अभी डिफरेंशिएशन का काम तो खत्म हुआ actually. अब जो अच्छा क्वेश्चन इससे बन सकता है, or not, Austin, not in this case. See, if we apply with the closed bracket, it means that x can take 1 and minus 1. And if you put x1, then you can see that the denominator is 0. No? So the good question in this part from this portion will include your good ITF skills rather than your good differentiation skills. Differentiation तो बहुत easily हो जाएगा. But there will be some functions or there will be some expressions given to you in which you will first need to reduce that expression. And after that, after reducing the expression, you will be, I mean, you need to apply the rule or you need to apply the formula of differentiation. But before that, let's first solve some other questions today because we will not be able to cover those kind of questions. So we'll be covering them. I mean, we'll be finishing this topic on next Saturday. Yeah, yes, Saturday का timing नहीं कुछ decide करा. Can you guys please help me with the timing of Saturday's class? So should I fix it anytime? Is okay. So I want to fix it Indian time here 3 o'clock, 3 p.m. Is it okay with everyone? 3 p.m. on Saturday. Saturday. Yeah. Five to 6:30. Okay. ठीक है. 5 to 6:30 Indian time on Saturday. Is it okay for everyone? Okay. Cool. Those so same time on Saturday. No, 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 Shai. 5 to 6:30. I mean, is it not okay for you? You can tell me that. Yeah, I also want it at 3 p.m. But okay, cool. But I think we are facing a problem with that. Cool. So we'll be having uh, an extra class on Saturday on the same time. Chalo then. Let's start with some questions. Mm, these will be basic questions only, not very fancy one. Start solving, please. This is 17 only. It may not be possible. I just want the answer for dy by dx. It can be in terms of x, it can be in terms of y. No need to worry about that. But yes, combine all the dy by dx. What you may have obtained dy by dx from more than one expression. So combine all the dy by dx, take that common, and then find out the final expression for dy by dx. Let's solve the first one. Okay. I know everybody is doing this, but I also want to solve. I'll help you out. I'm starting now. You guys please keep doing it. Keep continue whatever you are solving. You can tally with whether you are doing it correct or not. Actually, you can write it like this. This should be the final answer. You can also take y common from the denominator, but that won't be cancelled. I mean, that will just be simplifying the expression. But you can also write it like this. Uh, did anyone get the answer correct for first part? Just raise your hand if yes, the answer is yes. Okay. Are you facing a problem with question first? I mean, if you didn't get the answer correct, do you think there's a problem? Please specify, please. Shahid, we will be also solving out, this. Where did this y came from? I am not sure. I mean, one. Shahid, this is incorrect, but this is the correct answer which I got. Okay. You can take help, and if you can ask me if you have any doubt. And the second part, anyone? Okay, let me also help you out with the second part here. This is sine square y, right? This would be 2 sine y first. First, we will deal with the power. Then we will reach to sine. Sine is cos. Cos y. Then we will reach to y. Y is dy by dx. Right? Plus, then I'll reach to cos of xy square. First, I'll reach to cos. Right? Cos. Cos is minus sign. And the inside part is c. Then I will reach to x into y square. Now x into y square is what? Just similar like this expression. The answer must be this. So in multiplication, I will write y square plus 2xy dy by dx is equals to 0. So it becomes c. We do have 2 dy by dx. So this is 2 sine y cos y, which becomes sine 2y. If you're not familiar with these formulas, please, this formula, please check them out. This is 2 sine y minus, this becomes y square into sine of xy square. I'm basically multiplying this with the whole expression. This becomes minus 2xy sine of xy square and then dy by dx is equals to 0. So there are two terms which contain dy by dx. This first is this and second is this. And there is one term which do not contain dy by dx. So I'll take that term to the right hand side and combine both of these terms together. So I can write this becomes sine 2y from the first term, and this becomes minus 2xy sine of xy square is equals to This becomes y square sine of xy square. So your final answer for dy by dx actually becomes y square sine of xy square. I mean, now I'm just simplifying the expression. Everything is done. Please feel free to ask me any doubt.
Sir,
Yes.
can you scroll up? I was out.
Scroll up, Mani.
Yes.
We don't have the last page now, Shavis. We are only solving this part. I mean,
Okay, sir.
just applied our basic rules to the whole expression. Is everybody done? Please write this third part and this will be solving for in homework. I mean, you will, every one of you will be solving in homework. And also exercise 7.3, you will have to solve first 8 questions. First 8 questions from exercise 5.3. My bad. Not 7.3, 5.3.